My name is Saulo Solis. I'm in the program Biomedical Engineering Technology. A senior project to me is a process of first brainstorming ideas. There's a group of us. We all each individually come up with an idea, and we decide, well, our professor decides which is the best to be implemented. And then from then we move on to ordering parts and making sure that it will all work with our idea. And then we start building upon it and developing it as well. And then if needed, we can, once we finish completing our model or our prototype, we then see if we can improve upon it and if there's any changes we need to make. So it's a complete process from start to finish, and it's very interesting. Our project is a 3D printed prosthetic arm, and we want to make it available for people who can't afford prosthetic arms that are advanced in technologies, with electronics. They're able to move it with just their muscle movement and not just something mechanical. So we were bridging that gap from expensive prosthetic arms with electronics and those cheap mechanical 3D printed arms, and we merged that gap, and that's what we came up with. So what we have here is a 3D printed prosthetic arm, and we used a 3D printer to print all these parts, from the fingers to the palm and even the forearm. These are all 3D printed, and 3D printers are very affordable to make. So what we have inside are 5 DC motors, and you can't really see them, but each finger has its own DC motor because we wanted a hand that's able to grip firmly and hold on to things without slipping or dropping them. What we also have inside, and we had to learn all these parts as well from our electronics and engineering courses, are microcontrollers and power supplies, motor shields. We also needed to learn how to program what we wanted it to do. So programming is also required. Okay, so what we did to control this, we used an armband, which is a device that we had to purchase, and we didn't develop it. It was developed by a company in Canada, and it reads muscle signals. So what we were able to do in the program is make it talk to the microcontroller inside the arm. So we used an Arduino program, which is the microcontroller we use is Arduino, and the program that works with the microcontroller is the Arduino IDE. And so what I'm going to do is I'm going to connect it right now, and it will synchronize with the arm. So whatever my arm does, it will follow, hopefully. So we'll see. And there we go. And we also, in addition to that, we put a servo motor in the thumb so that we can make it move in and out as well by moving your arm, your hand. So we can, in addition to just opening and close, we're able to do that. There we go. All right. And that's our project. So one of the things that we learned as a group, because I'm not the only one that worked on this project, we were a team of 4, and so one of the important things that we learned was how to work as a team and divide the job of putting this together evenly between us, working on the research, part research, the design as well, and the programming, which we all weren't too proficient with, but we learned enough to be able to work with the programs that work with the microcontroller. Another thing that we learned was time management, very important. We had to find, from our busy schedule, and all of us have other things going on in our lives, we had to find time to get together, meet and talk, discuss about the project, working on the project, the development, putting the parts together, as well as learning how to, like the Arduino program, we all didn't know how to use that, so we had to learn how to use that program as well, which is, I believe it's C++ based. We knew how to do C++, which we learned from here, and so it's very similar, so it wasn't too hard to do. So we were comparing other prosthetic arms that are already designed, because obviously this is not a new idea. People have come up with these as well, but this is our own prototype, and we were comparing, contrasting what is good, what parts work well together. Battery supply. Another problem we had was having a good enough power supply to last for whoever wants to use this arm. We wanted to last at least 6 hours, which is we were able to accomplish at least 6 hours of battery life of use before they had to recharge the battery. And that's another thing we used was rechargeable batteries. So that's I think that's pretty much all the problems we encountered during this project.